Okay. In a two-player, one-shot simultaneous move game, each player can choose strategy A or strategy B. If both players choose strategy A, each player earns a payoff of 500 kwacha. If both players choose strategy B, each player earns a payoff of 100 kwacha. If player 1 chooses strategy A and player 2 chooses strategy B, then player 1 earns 0 kwacha and player 2 earns 650 kwacha. If player 1 chooses strategy B and player 2 chooses strategy A, then player 1 earns 650 kwacha and player 2 earns 0 kwacha. Okay, so part A, write the game in normal form. Okay, so colleagues, this is the normal form of the payoff matrix. Okay, you have player 1 on this side here, and you put it in red. Player 1, and you have player 2. Okay, you've got, so for player 1, the strategy A, the strategy B. For player 2, the strategy A and strategy B. Okay, so remember in the question it says, if both player, oh, is it? If both players choose strategy A, each player earns a payoff of 500 kwacha. So have you seen? Strategy A. Both players choose it. Player 1 chooses strategy A, player 2 chooses strategy A. Both of them have payoffs of 500 kwacha. Remember, what's in red is for player 1. What's in blue is for player 2. Yes? Yes, yes, go ahead. Game theory and market structures. Yes. Not really in bola bet, but this is, you are trying to see how companies behave, how they react to if one chooses a certain strategy. All right. I've also got the notes. I'll give you the notes for this. Okay. I'll give you the notes. Game theory. Game theory. Here it is. It's a study of how people make decisions when their choices affect each other. Okay. So how people or companies make decisions when their choices affect each other. That's what game theory is. Okay. So we're back to the payoff matrix. All right. We've said if both players choose strategy A, each earns a payoff of 500 kwacha. Okay, 500, 500. If both players choose strategy B, each earns a payoff of 100 kwacha. Okay. So player 2 strategy B, player 1 strategy B. Have you seen? B here, strategy B here. So we're talking about this one here. Okay. If both players choose strategy B, each of them earns 100 kwacha. If player 1 chooses strategy A and player 2 chooses strategy B, then player 1 earns 0 kwacha and player 2 earns 650 kwacha. Okay. So if player 1 chooses strategy A and player 2 chooses strategy B, so we come here. Player 1 chooses strategy A and player 2 chooses strategy B. So we're in this box here. Player 1 has chosen A, player 2 has chosen B. Okay, so we're in this box here. Okay, player 1 has chosen A, player 2 B. Then it says the payoff will be player 1 earns 0 kwacha and player 2 earns 650 kwacha. Okay, so player 1 0 kwacha, player 2 650 kwacha. Then if player 1 chooses strategy B and player 2 chooses strategy A, then player 1 earns 650, player 2 earns 0. So player 1 chooses strategy B. Player 1 strategy B is here. Player 2 chooses strategy A. So player 2, this is under strategy A here. Player 2 strategy A, player 1 strategy B. So it's this box here. All right. Player 1 in 650. Player 2 gets a 0 kwacha. Any questions, colleagues? Because if you mess this up here, it's game over. You get the rest wrong. Okay. So this is the payoff table here. Okay. All right. Part B, find the dominant strategies if any. So colleagues, when we say dominant strategy, this is what it means. A strategy is dominant if it gives you a better payoff no matter what the other player does. Okay. Basically, no matter what they pick, this is my best move. Okay. So it gives you the best payoff you get no matter what the other player does. Okay. So let us start. We're going to look at player one's for the dominant strategy for player 1. Okay. So we're going to the dominant strategy of player 1 is going to be based on what player 2 chooses. Okay, colleagues? The dominant strategy of player 1 is going to be dependent on what player 2 chooses. Okay. So for example, if player 2 chooses A, strategy A here, all right, it means they're getting a payoff of 500 kwacha. Okay, they're getting a payoff of 500 kwacha. So player 1 can also choose strategy A, but you get a payoff of 500. Or he can choose strategy B, which is going to get a payoff of 650. So remember the dominant strategy, you have to be better off. All right. As we said here, dominant strategy, the better payoff no matter what the other player does. Okay. So if player 2 chooses strategy A and gets a payoff of 500 kwacha, player 1, the best decision is to choose strategy B and get a payoff of 650. Okay. If player 2 picks strategy A, they get 500. So player 1, the dominant strategy is to pick strategy B. They get a payoff of 650. Because if they choose strategy A, they're going to get the same payoff as player 2. Okay. So it's better to choose strategy B where you've got a better payoff of 650 kwacha. Any questions? Okay. If player 2 chooses strategy B, okay, player 2 has chosen strategy B, it means they're getting a payoff of they're getting a payoff over 650 kwacha here. All right. So player one, if he chooses strategy B also, is going to get a 0. If he chooses strategy A, he's going to get a 0. So the best he has to choose strategy B, at least he's going to get a 100. All right. So player two has to pick strategy B again. All right. So player one's dominant strategy is strategy B, because have you seen? No matter what player two has chosen, A or B, player one is going to just choose B because B is giving the better results. Any questions before we got to the dominant strategy for player two? Okay. So player two's dominant strategy is going to be based on what player one is going to pick. So if player one picks A, okay, player one has picked strategy A. Are you able to get now? Okay, we're looking at the dominant strategy for player two. All right. So this is going to be based on what player one is picking. Our choices are going to be dependent on what player one picks. Okay. So you start with the first scenario where you say player one picks strategy A. Okay. So when player one picks strategy A, they're going to get a payoff of 500 kwacha. Okay. So the options player two has is either you pick this 500 kwacha here or you pick this 650 kwacha here. All right. So 650 is higher than 500. So player two is going to choose 650 here. Okay. Because it's better than 500 here. So the player two will choose strategy B. Okay. If player one picks strategy A, definitely they're not going to go for this payoff of 0. They're going for this payoff of 500. So it means player two has got two options, 500 or 650. You pick the higher option, 650, which is strategy B. Scenario 2, where player 1 picks strategy B. If player 1 picks strategy B, it's either they can get this 650 here or the 100. Definitely they're going to get the 650 there. Now for player 2, the two options is either you pick 0 or 100. The better option is to pick 100 because 100 is greater than 0. So if player 1 picks strategy B and gets paid 650, player 2 is also going to choose strategy B where they get paid 100 because they don't want to get this 0 here. All right, so they'll pick the 100. So with both scenarios again, player 2 is choosing option B. So option B is the dominant strategy for player 2. All right, colleagues? Yes, the dominant strategy, whatever the other player chooses, you're still picking the same strategy. That's the dominant strategy. So if player 2 gets A or B, player 1 is just choosing B throughout. If player 2 gets A or B, player 1 is just picking B throughout. Yes. Any questions? Okay. Part B, I've done. Part B, we've done. Part C, find the Nash equilibrium. Okay, here's the definition of Nash equilibrium. A Nash equilibrium happens when no player wants to change their choice after seeing what the other chose. In other words, I'm happy with my choice and you're happy with yours. Neither of us would change. Okay, so basically, the Nash equilibrium here is going to be where both players choose strategy B, because that was basically their dominant strategies. Player one's dominant strategy was B, player two's dominant strategy was B. So basically, the Nash equilibrium is where both players choose B and B, where the payoffs are 100 and 100 here. Okay. So you're going to look at the dominant strategies, and then that will give you your Nash equilibrium. The dominant strategy for player one was B. The dominant strategy for player two was also B. Okay. So when both choose B, A and B, I mean, both player one and player two choose B, B, it means the payoffs are going to be these 100 kwachas there, which gives us the Nash equilibrium. Any questions? Okay, part D, rank strategy pairs by aggregate payoff. So we're just going to see which pairs are giving us. We're going to rank from the highest payoffs to the lowest. Okay. So if player one chooses strategy A and player two chooses strategy B, the payoff is 0 and 650. So when you add 0 plus 650, you're going to get 650. Okay. Player one has chosen A, player two has chosen B. Okay. Player one has chosen A, player two B. So it's this one here, okay, colleagues? There it is. Okay. Player one A, player two B. That's the one there. Player one chooses B and player two chooses A. Player one has chosen B and player two has chosen A. It's this one here. 1B, player 2A. Right, so again, 650 plus 0, 650. Right. If player 1 chooses strategy A and player 2 chooses strategy A, both of them are both on strategy A, it means it's this P. So the total payoff 500 plus 500, that is 1000. Then if player 1 chooses strategy B, player 2 strategy B, player 1 strategy B, player 2 strategy B, it's this one here. All right, so the total payoff 100 plus 100, 200. So we rank them. The highest payoff is strategy AA, 1000, so you rank it as number 1. Then strategy AB and strategy BA, they give both payoffs of 650, so you rank them as 2 and 2. Then strategy BB gives the lowest payoff of 200, so you rank it as number 3. Any questions? Can the highest aggregate payoff be sustained in equilibrium? Explain. Okay, so remember the highest payoff is AA, which is 1000. All right, but it's not the Nash equilibrium. The Nash equilibrium, what was that 100, 100, which was B. Okay. So if player 1 plays A and player 2 plays A, Player 1 can switch to B and get 650 instead of 500. Okay, meaning, for example, if they both want to choose this one here, these highest payoffs, one can change and player 1 can change and say, okay, I don't want this 500 payoff. Let me choose B, and they'll be better than player 1. And also, player 1 can also do the same thing. They can refuse this highest payoff and go to strategy B. Because remember, here, no one is trusting each other. In this game theory, remember, no one is trusting each other. So, if both try to choose this one, they'll still won't trust each other that they're going to maintain these payoffs. One can switch to get the higher payoff, either player 1 or player 2. Okay, so basically, the best total, which is the aggregate payoff, this highest aggregate payoff, cannot be stained because both players cannot trust each other. Simple as that. Both players cannot trust each other, so this payoff of 1,000, where both choose 500 and 500, it cannot be sustained for a long time. Why? Because eventually one will choose a payoff that's higher than their friends. Okay. So it cannot be sustained because there is no trust between both players. One will eventually choose a better payoff than the other. Okay. Yes. Any questions? All right.